Okay, so today let's go ahead and get this section covered. We're going to be doing 4.2, which is writing equations in point slope form. Let me go ahead and shut off this projector so we don't have a glare. Okay. Now, yesterday we did slope-intercept form, and one of the things I mentioned was slope-intercept form requires two things, slope and intercept. Today we're going to be covering a slightly different form. It's called point slope. Guess what two things you need for this one? A point and a slope. So this highlights what they had started to ask towards the end. We even did a question where I messed up like twice in a row. So today I get to kind of redeem myself and say, hey, here's what we're going to do. It is a method where instead of needing a slope and a very specific point, specifically the y-intercept, we can take any point that we want, no matter where it is on the graph. So we call this not slope-intercept form, not slope any random point because it doesn't matter if it's the intercept or not form. We call it slope at any random point that doesn't matter whether or not it's the intercept or not form, or if I say in reverse, point slope form. But that's what this is. It's about what happens if I don't have that very specific point. What if I'm over here on the graph and I don't want to have to work my way all the way over to where it crosses that y-axis? Here's what we do. So if I have plugging in the point and the slope, so I'm going to be plugging it into this formula. Now, the parts of the formula that I'm going to be replacing are going to be y minus y1 equals m times x minus x1. I'm going to be replacing what I've written here in red. I'm going to be replacing the slope and then the point with the x and the y. Now, one of the things I asked, and I'm getting about 50-50 return on this, is what comes first, the x or the y? A lot of the students are forgetting this, so I reminded them. We have a song that we sing to remember which one comes first in the coordinate. So it goes, which one comes first in the coordinate? I'm kidding. We don't actually sing that. This is the song that we sing. We sing this. A, B, C, D, E, F. That's not how the alphabet song goes. G, H, I. I don't know how the alphabet song goes while I'm singing this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. X, Y, Z. And I remind them, okay, which one comes first? Is it X or is it Y? X comes first. So they laugh, they moan, they groan. Oh my gosh, the world is ending. I had to sing the alphabet song here in math class. But it gets a point across. X comes before Y because you already knew that. So this is going to be my X, this is going to be my Y. I just plug them in. So I get a Y minus 4 equals a slope of 1/2 x minus 8. And that is the answer to number 1. We're just plugging it in, making sure we understand how to work the equation. Easy enough. For number 2, we're going to do the same thing. Let's go round 2. Oh, pause. My y value is negative. Is that going to be something weird? Yeah, let's take a peek. So again, I'm always writing out. Our bell ringer today was write out the formula, because I now have two options. You need to say, I'm using this option. This is the big thing in later classes that we need to make sure that we're aware of. So we always write out which formula we're using. Y minus y1 equals m times x minus x1. Okay, I'm going to plug in the x, the y, and the m. Now, if I plug in the y, what I get is I get y minus a negative 8. The negative 6 for the slope is fine. The x minus the 2 is fine. But I asked them, I'm like, what happens when I subtract a negative? Well, that ends up being plus a positive. And they're like, what? Oh my gosh, that's crazy. And they lose their minds. But here's the deal. If I subtract a negative, it ends up being plus a positive. So I'll keep that in mind. If I see a plus there, I know there must have been a double negative. If I see a minus, I know I'm just subtracting a regular old positive number, nothing crazy. So what happens if they're both negative? Well, I just do the same thing again. I say, okay, I have y minus y1 equals m times x minus x1. Now again, I know that if I have a double negative, it's going to show up as a positive. I'm going to do it the long way right here so you can get the idea for it. But realistically, what we're doing is I'm going to say y plus 8 equals 10/3 x plus 6 right off the bat. If you want to see it the long way, it's going to end up becoming y minus a negative 8 equals 10/3 x minus a negative 6. And for both of those double negatives, minus a negative is going to end up becoming plus a positive. Minus a negative is going to end up becoming plus a positive. So again, anytime I see a plus sign, I know it must have been subtracting a negative. Anytime I see a minus sign, I know it must have been a positive originally. And that's a big key point because most of the time when they're making equations like that, they'll get those negatives flip-flopped and problems happen. And we would rather avoid simple mistakes like that. Now for the next set of questions, we're doing the exact reverse. I'm going to take the equation and say, can I figure out what the slope and the point are? And the answer is pretty straightforward. For this one, I'm going to say what number is in the m position for the position of the slope. So this slope is going to be a 6. Now, most of the time when you're doing questions like this and you're pulling information out, it's because you're about to graph it. So I'm going to go ahead and tell them, make sure the slope is in graphing format, which means I need a rise and a run. I need a fraction. So I have a 6 over a 1. Okay? The coordinate, remember what we said right here. If I see a positive, it must have been negative originally. If I see a negative, it must have been a positive originally. The x minus, what number am I subtracting? I'm subtracting a 12. If I see a minus, it must have been a positive. I'm subtracting the number. So the number is 12. I'm subtracting a number. The number is 5. Because if I see a minus sign, I know that it must have been a positive originally. So again, if you want to think about it, minus means plus, and then plus will mean minus. But really, it's what are you subtracting that number, okay? So again, for this one, the only difference between 4 and 5 is the signage. So the slope is going to be the same. This slope is 6 over 1. But I'm not subtracting anything. I have a plus sign, which means that what must have been there before that plus sign popped up? I must have had minus a negative. So what number am I subtracting? A negative 12. So my number in this case is a negative 12. Well, how did you know that? Well, I knew that because the plus sign was here. Remember, if I see a plus sign, I know the number must have been a negative originally because there was a double negative. So the double negative means I'm subtracting the negative. So what number am I subtracting for y? There must have been a double negative here. I'm subtracting a negative 5. Okay? And this is a lot of students at this point. Oh, I get it. Like I've got a lot of students that were getting it at this point. So awesome. With this one, my slope is going to be a 1/2, so 1 over 2, a rise of 1, a run of 2. I'm subtracting, so that positive right there means there was a double negative. So my x must have been a negative 1/4. Okay? There's no double negative here. The number that I have for my y is 1/3. So again, I just identify my point, my slope. Now again, most of the time with questions like this, you're graphing them. In fact, the homework that they're going to have, they're graphing those things. But for right now, I just want to make sure they get the idea of can we pull out the information so that we could then spend time in class on other questions and they'll do the homework later. Number 7 was a doozy. Each class I gave them a trial where I said, hey, first 5 people to get it, and I gave out like popsicles, or I had some like bags of chips that I bought from some students that I gave out for other classes. I think it was Latin Club. So you're welcome, Latin Club. I bought a lot of chips for you guys. I said, hey, if you get this, raise your hand, let me know. A lot of them got it. A lot of them had some issues with that. So I'll give you a moment, pause the video, see if you can't figure out number 7, unpause it when you're done, and see how you compare to what we did. Should have had a chance to pause it by now. Let's go ahead and take a peek. So I have a negative 3/4, so my slope is a negative 3/4. They got that. A lot of them got the fact that they said the x was a negative 6 because there must have been a double negative there, subtracting the negative. But then here's where they got confused. They didn't have anything else to put, so some of them just put another negative 6. Some of them just put another negative 3/4. Some of them didn't know what to put. But again, what number am I subtracting from y? Nothing. I'm subtracting nothing from y. What do we represent nothing with in math? A 0. I'm subtracting nothing. So what is the y coordinate? A 0. Bingo. So I'm going to pause the video, move to the other board, and let's continue. Okay, so here's the other board. We're going to write an equation in point-slope form. So just like we did earlier on numbers 1, 2, and 3, we're going to knock out 8 and 9 just like that. I didn't give you the point in the slope and wrote it down, but I gave it to you. You got to figure out what I gave you. So with this, I know the equation that I'm trying to fill in is y minus y1 equals m times x minus x1. I need those three things. I need a slope and I need a point. So I've actually got two separate points right here. I can either use this point, which is a 3, 1, or I could use this point, which is a -3, -3. You have your option of either one of those. Okay? So as I plug it in, I know I have a y, I'm just going to use this first point, -1 equals some unknown slope, I'll leave that blank for just a moment, x minus 3. So what I chose was I chose this one right here. I plugged that in. Could I have plugged in the other one and gotten a y minus a -3, so plus 3? And I could have gotten x minus a -3, which would have been plus 3? Yeah. I could have plugged in this point instead. So I have two possible answers here. Both of them are correct. Doesn't matter which one you pick, just as long as you pick one of them. Okay? And then I need the slope. So all that you do to find the slope is you just count from point to point. I went up 2 over 6. So I say, okay, up 2 over 6. I would have done the same thing right here. I would have said up 2 over 6. Now for both of those answer choices, both of them actually reduce one step further. 2 over 6 does actually reduce. They both divide by 2. So 2 over 6 becomes 1 over 3. Same thing up here. 2 over 6 becomes 1 over 3. So you have two possible answer choices, either the top or the bottom, depending on which point you picked. Doesn't matter which one, as long as you picked one of them. Feel good about that? Let's do another one. So on this one, again, I know I have a point. I can figure out the slope here in a moment, so I'm going to use point slope. So y minus y1 equals m times x minus x1. Okay? So now I have this point over here, which is a -2, positive 4, or I have this point over here, which is a 2, 1. Okay? Again, it doesn't matter which point you choose as long as you pick one of them. So I'm going to plug whichever one in that I want. If you picked the first one, I'm going to get a y minus y1, which is 4. Don't know what the slope is yet. X, I'm going to get minus a -2. We know minus a negative is going to end up looking like a plus a positive. And then all I need to do is find the slope. Down 3, and I go to the right by 4. So I go down 3, right 4. But Mr. Johnson, I picked the other point. Okay, cool. So you would have gotten, instead, a y minus 1 equals down 3, right 4, x minus 2. Both of these are correct. It doesn't matter which one you picked as long as you picked one of them. So both of these are correct answers. Again, it doesn't matter which one you picked. So now that this is the green one, yeah, the green one's dying. That made it in. Don't believe anybody that said anything else. Okay, new green marker. So we've got this. Now the last one here is I just gave 2 points. There's no slope given. So a lot of them freaked out about this, but a lot of them immediately saw. I had about 50-50. Some classes freaked out. Some classes were like, oh, I know how to do this. We just find the slope. Can we graph it? Sure. Graphing's the hardest way though. There's 3 ways that we can do this. So let's take a look at the 3 ways. So I'm actually going to, we're going to take a pause right here on this. If you need any else, take a screenshot real quick because I'm about to erase some of this. Let me pause the video and rewrite this board for those 2 questions. So here are the last 2 questions. So I rewrote them because I gave it a little more space because, again, there are 3 possible ways that we can solve this. There is method A. How do I do this? A, B, C? Yeah. Let's do A, let's do B, and let's do C. Hopefully that's enough room. If I need to move over a little bit more, I can. Okay. So there's 3 ways we can do this. Now, slope, remember we had that big, huge equation for slope because it has multiple parts that you could use. Do you want to use a crescent wrench? Do you want to use an adjustable wrench? Do you want to use a ratchet and socket? Do you want to just use a good old-fashioned like wrench that only has one size? You get to pick. They all do the same thing. You got to twist a bolt on something. So for the first one, and the most common one, this student said, hey, isn't there one where I can say y2 minus y1 over x2 minus x1? The answer is yes, we can do that method. That method is already ready to go for coordinates. So those are the ones who really know what they're doing. So let's take a peek. So that means that my slope is y2, which is 9, minus y1, which is 6, over x2, which is 3, minus x1, which is 2. 9 minus 6 is 3. 3 minus 2 is 1. There is my answer. Or if I want to, I could just put that as a 3. You have 2 possible options. So I have a slope, and I can then use that to fill it out. But before we begin, I'm going to do a different method. There's a different method for a lot of the students, and this is about 50-50 between A and B. Half like this method, half like the other method. Pretty much nobody does C, but I'm going to show you C anyway because it's a third way, and it's an easy way. It just takes a lot of time. Okay? Method B was they're like, well, can't we do what we did yesterday and we build a table? So he said change in Y over change in X. And I said, yeah, but you got to build the table. And they're like, okay, well, let's build a table. X, Y. Okay. My X is 2, my Y is 6, my X is 3, my Y is 9. And for delta Y, I need to know what is the change from 6 to 9. It went up by 3. So I went up 3 over the change in X says what happens over here. I went up by 1. So I have a plus 1. Bingo. I have a 3 over a 1. Or if I want to, I can just write 3. So you notice how we got the same values right there? Option C is a little ridiculous, but okay. Option C says, I just want to do the good old-fashioned rise over run. And this is where we're going to graph the thing. I'm going to say, okay, I need to get a graph on here. Let's pause real quick. I'm actually going to rotate this so I can use the existing axes. X, Y. Okay, I'm going to plot these points. 2, 6, 3, 9. So 2, 6, and 3, 9. This red is dead as well. See if I can make it. That also made it. 2 for 2. Okay. New red marker. It still needs to warm up, but oh well. There we go. I got those 2 points. And so all we're going to do is I'm going to count. I'm going to say, okay, if I graph these 2 points, my rise, I went up by 3. So I said up by 3. And then I went to the right by 1. So right 1. Up 3 is a positive 3. Right 1 is a positive 1. So this is going to be a 3. See how all 3 of these methods all yield the same results? It's because it doesn't matter which method you use, you're going to end up with the same thing. So I have a slope, or a slope if I want to graph it, if I want to build a table, or if I want to use the coordinates. It doesn't matter which one. Most students picked one of these 2 methods, though. I had, I think all day, maybe 2 students who liked this method. You do you. Doesn't matter which one, as long as you're showing your work, I'm happy with that. If I do see that you wrote rise over run, I'm expecting to see a graph. If I see delta y over delta x, I'm expecting to see a table. If I see these, I'm expecting to see coordinates. So again, you do you. At the end of the day, what you're going to be doing is that you're going to saying, hey, y minus y1 equals m times x minus x1. I'm I'm going to plug in again. You have either one. I'm just going to plug in the top one, though. So I'm going to say y minus 6 equals 3x minus 2. If you wanted to plug in the bottom one as your point, you have another answer that you could put. It would be y minus 9 equals 3x minus 3. So you have, again, two possible answers here, top or bottom. It doesn't matter which, as long as you make sure you commit. So that being said, I did the same thing as I did on number 7 over there. I gave them a pause and said, how about you guys figure out the slope on number 11? It's a little trickier than you would think because we're going to have to pay attention to our signages. So if you want to, give the video a pause, try out number 11. Specifically, just really try out getting the slope. Pick one of these methods and find the slope. We'll do the whole equation together once you're done. So pause it and give it a shot. Hopefully it's paused at this point. So let's go ahead and give this method a shot. Now I'm going to go ahead and erase method C because, again, nobody really used it outside of like 1 or 2 students. I'm just going to save the space. Bingo. Okay, so if I used method A said I'm going to find my slope using y2 minus y1 over x2 minus x1 because it's ready to go for a coordinate. My second y is going to be a negative 2, and I'm subtracting my first y, which is a 5, my second x, which is a negative 1, and I'm subtracting my first x, which is a negative 4. First thing I noticed is I told my students, you notice those double negatives? Yes, you do. Double negatives means that's going to end up becoming plus 4. Okay? So negative 2 minus 5 is a negative 7. Negative 1 plus 4 is going to be a positive 3. There's my slope. Okay? Let's say they didn't like doing that method. They liked building the table. Okay, let's go ahead and build ourselves a table. There goes my top. Okay, I have a negative 4, negative 1, 5, negative 2. Okay, I need to figure out what the y's are doing. Now, the number one thing that I saw people do, because if you didn't get that number, here's what you probably did. You probably did this method, and you said, 5 to 2, I went down by 3. And then you probably also forgot these guys. You ignored the negative signs. This is the number one thing I saw. I saw this in approximately like 20% of the students. So please pay attention to this. They said, I went from 4 to 1. I also went down 3. What's negative 3 over negative 3? Positive 1. They got a slope of 1. Can't do that, okay? Because remember, I didn't go down to 2. I went down to negative 2, so that's a lot further. I actually went down by 7. I didn't go from positive 4 to positive 1. I went from negative 4 to negative 1, which means I didn't go down 3. I went up 3. Okay? And the formula for this one is the slope is delta y over delta x. My delta y is negative 7. My delta x is a positive 3. Okay? If you wanted to graph it, you could graph it and count the numbers. Do we need to graph this one? No, but I'm going to do it anyway, just in case one of you out there is doing this method. If you don't like this method, skip it. Skip ahead to the point in the video where we've already done this method. Also, if you are using this method, leave me a comment and say, I like this method. Can we do more of it? So that way I know you like this method. But as of right now, the students in class do not. There's my y. There's my x. Crap. That's not where I need to put my y and my x. I need to put this in the center. There's my y. There's my x. Okay, so negative 4, 5, negative 4, 5. I'm all the way up here. I have negative 1, negative 2. I'm all the way down here. Okay, so what I'm going for right there is I have a rise of going down 7. So where am I going to put this? Let's call this part C. The M is rise over run, which tells me you have a graph somewhere. I've got a graph. My rise was down 7, which we know is -7. My run means I went over 3. So I went to the right by 3, which is a +3. And guess what? You got the same thing as everybody else. But that one, again, I don't normally do this method. Most students don't do this method, but the ones who do really, really, really like it. So again, if this is the method you prefer, leave a comment, let me know so I can keep including this in future videos. Otherwise, for the most part, I'm going to skip using methods like this for finding slope. I'm going to stick with one of those two, most of the time, method A. But go ahead and take a screenshot if you need to, because 3, 2, 1. It is getting, actually, no, I'm not going to erase that one because I got enough room beneath it. Okay, either way, let's take a look at what we're doing here. I need to write in the formula y minus y1 equals m times x minus x1. Okay, so if you picked the top point of -4, 5, you would have gotten this as your answer. Y minus 5 equals a slope of -7/3. X minus a -4, which is going to end up being +4. If you picked the other point, you would have gotten y minus a -2, so +2. Same slope as before, 7/3. And then I would have gotten x minus a -1, so it would have been a +1. Okay? So no matter which one of these you got, one of these is your answer depending on which point you picked. Kind of crossed out have my answer though, but okay. So again, this was a super easy day. Students really liked it. They blew through it really quickly. I included a few extra methods because depending on which class, I may have shown you more of that method, more of that method, more of that method. Again, this video is a little longer than what we did in class because I'm showing you everything for all day. Let's take a pause, go check out the homework. Okay, so today we covered 4.2. We did the lesson and the homework. Tomorrow, we're actually going to be doing practice, so we're going to do an activity over 4.2 and 4.3. Don't know what I'm actually going to call it. Are we going to do a worksheet? Or are we going to do Delta Math? I'm going to look at that. Regardless, we are going to be doing practice over these two lessons. The homework we also know is going to be due tomorrow. Homework is going to be due on Fridays. Now, the homework that we have here is on page 190. We're doing numbers 1 through 12 all. Both of these are due tomorrow. So regardless of whether or not you've started the homework, please make sure that we are going to be finishing it tomorrow because we're going to be turning that in. And then the first few questions on 4.2 are going to be graphing questions. So just make sure that you get those on graph paper. Mom, Dad, if you haven't bought graph paper by now, we really need graph paper because a lot of these, we need to have accurate graphs. We need to be counting squares. And for good or for worse, some of your kids can't draw a straight line to save their lives. You need graph paper because their lines do this. It's going to be really hard to count when this part of the line only says 2 to the right and this part of the line looks like 5 to the right. So again, not being mean, I'm just being honest here. Get graph paper for your kids. If you have any questions, let me know. Otherwise, I will see you all tomorrow. Have an excellent day.